little bit more advanced. Sound good? You there still? Sorry, looks like I lost you real quick there.
No, it's okay, yeah.
All right, so all right, simplify logs. Well, this one looks to me like it would be one, just going with my gut, that I would do change of base. So I'm going to change them all to base 10. So change of base says that's equal to log 2 or log base 10 of 3 over log base 10 of 2. This is log 4 over log 3, right? This is log 5 over log 4, and you see what's going to happen, right?
Yeah,
Log
I
6
do.
over log 5, log 7 over log 6, log 8 over log 7, and then all these things are just going to cancel. Boom, 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 boom. And my answer is just log 8 over log 2. Now that can be converted back into base 2. So this is just the log base 2 of 8. And of course, what's the log base 2 of 8? That's the same as, that's like saying log base 2 of 2 cubed.
Yeah.
So that's basically like saying 2 to what power? 2 to what power equals 2 cubed? Well, that's just 3. So that entire thing just equals 3. All right, I need to review what the meaning of log is real quick. Here we go. Tell me what you think the log base, give me an estimate of log base 3 of 5. What do you think the log base 3 of 5 equals? Do you have an idea?
It could be 1.2.
Good, that's a good guess. You know that this just means 3 to what power equals 5, right?
Yeah.
So you're guessing, well, you know, 3 to the first power is 3, and 3 to the second power is 9. So 3 to what power equals 5? It's somewhere between 1 and 2, closer to 1, right? So if we use our calculator and we could just type in log 5 divided by log 3, because that's the change of base formula, and it'll give you the answer. It's actually 1.46. Okay? So
Yeah.
let's go back, because I asked this question. What's the log base 2 of 8? That means 2 to what power equals 8? Well, 8's a power of 2. So the answer is right there. It's just 3.
Yeah.
You could have also brought that down front, right? And then that's gone using those properties. Anyway, so there's your answer 3. Got it?
Yeah.
Okay, solve the following. All right, so we're trying to solve this. Well, we're going to have to combine these together. So this is ln of y equals, remember how I combine them? I can multiply all these together, right?
Yeah.
I can just multiply. This equals the ln of cx squared plus cx, right? Because I'm just multiplying all those numbers together. You follow how I did that?
Yes.
Which means y, so now I can exponentiate both sides, base e. So that means y equals cx squared plus cx. So I'm not sure what they want you to solve here. So y equals, I can factor out a cx, obviously. So that's just x plus 1. So when they said solve, I can't really solve it. I can simplify the equation, but I can't actually solve that.
Yeah, I think that we're just supposed to, I guess that simplifying it would just work fine here. I think for this one, yes, you're supposed to simplify, but for number 2, I think it's going to be a bit different.
Yeah, it is. But I think for number one, what they were probably after is solve, like find the x-intercepts maybe.
Yeah, I think so.
That's probably what they would have done. So the x-intercepts, if they wanted you to solve for x-intercepts, if they wanted, I'm not sure if they wanted, but I would think that they would have wanted you to do that, would be x equals 0 and x equals -1. Got it?
Yeah.
That is if they wanted you to solve. I don't even know. I'm not sure. I'm not even going to write that because it seems a little bit ambiguous there. Definitely number two we can do, right? So what's the first step? Log base
So
3 of x to the 1/2, right?
yeah.
Equals log base 3 of 2 squared. So you can exponentiate both sides with a base of 3, which will just give you x to the 1/2 equals 4, which means x equals what?
Equals 1/4
Nope.
or 1/2.
Nope. How do I get rid of a 1/2 power?
You have to
How do I?
take the square root.
Nope, because it is a 1/2 power.
Oh, you
It is,
square
that
it. You
is the
square
square
it.
root. That's right. I square both sides.
So you got 16.
So x equals 16. And if you plug it in, you can check it. Now, this might be a no calculator test, but again, one way to check it is to just plug in 0.5 log base 3. If you have the ability to do log base 3 of 16, hit enter. That's some crazy number, but now type in 2 times log base 3 of 2, 2 times log base 3 of 2, and you should get that same number, which you do. So that's one way you can check. Okay. Good. Stop me if you need more help. Looks like we already did those top two.
Yep.
Yeah. So number 3, what's your thought? What should we do first? Any ideas?
We should subtract one of the logs, so there's only one log on each side. That's what
That wouldn't.
my math
Yeah,
teacher said that would be better.
well, sometimes that's good, but not when you don't have all logs. If you only had
Okay.
2 logs, that's a good thing to do. But in this case, that wouldn't help us. That wouldn't help us. In this case, what we want to do is combine these logs together. How can we combine logs together? Do you remember? The first thing we're going to do is bring this 3 up to the top, call it x minus 1 cubed, right? And then remember the property. What do? When you're adding 2 logs together with the same base, what can you do with the?
You can multiply them.
Yeah, you can multiply them. So this is actually log base 2 of 4 times x minus 1 cubed equals 5. Okay.
Right, that makes sense.
And now, see, now what can I do with this? Do you remember how you can convert this now, since it's just one single logarithm? How can you convert that to an exponential? Do you remember the equivalence? Well, let me remind you. If you have log base b of y equals x, that's the same thing as saying b to the x equals y.
So for this one, you could just say 5 to the power of.
No, look carefully.
Oh no, it would be 2 to the power of 5 equals 4 x minus 1 cubed.
Perfect. Now what? Now how can I solve this? By the way, this is just 32.
Yeah, 32.
Now what?
And then you can divide that by 32.
Well, remember we're trying to solve for
you can divide
x.
32 by 4. That's what I meant to say.
Good. Yeah, good. So this is actually, we're going to leave it as 2 to the 5th just because it's better. It's better, in my opinion, to leave it as powers. And over 4 equals x minus 1 cubed.
And
Now
then
what?
since it's cubed, you can just take the cube root of both sides. And then the
Perfect.
cube root of 8 is 2. So you get x minus 1 equals 2.
Well, we don't have 8 anywhere. Oh, we do have 8. I'm so sorry. This was 2 to the 2nd. You're right. So that's actually just 2 cubed. Very good. So now that's right. I didn't even see that for some reason. So now we have x minus 1 equals 2. Good. Which means x equals
3.
3. And you can plug it in to check to see if it works. 3 minus 1 is 2. Log base 2 of 2 is 1. 3 times 1 is 3. Log base 2 of 4 is just 2. So actually, at the very beginning, we could have just converted that, called that 2. That would have actually been even easier, right? So an alternative way, now that we're done, I realize what would have been quicker is if we just rewrote this like this: log base 2 of x minus 1 cubed plus 2 equals 5, right? Simplify that to 2. And then you could just subtract 2 from both sides. So it would have been log base 2 of x minus 1 cubed equals 3. Then you could have converted it. 2 to the 3rd equals x minus 1 cubed, which means 2 equals x minus 1, which means x equals 1. I'm sorry, x equals 3. So that actually would have been a little bit quicker. Okay.
Yeah.
All right, number 4, solve this for x. Okay, a couple ways to do this one as well. What's the first step I should do for this one?
The first thing to do is you can convert this to log form.
You could. You could. Because that would get the x out of the numerator, right?
Yep.
I mean, out of the exponent, the variable out of the exponent. So how would you like to convert that?
It would just be log base 8 to, no, log base 8 of 1.2 equals negative x.
Good. And so what does x equal?
X equals negative log base 8 of 1.2.
Good. Now, does your teacher want you to write it in exact form?
No, I think this is non-calc.
Okay, so that's probably the right answer because 1.2 is not a power of 2, right?
Yeah, I
You
was
can't
wondering if we
think of,
also were to, with the 8 as the base, I was wondering if I think that in the past we've had problems where you could just convert that 8 to 2 to the power of 3. I'm not sure if that
Mhm.
would that would really apply here because I feel like you'd have to convert it back.
Right. Sometimes you want to do that. Sometimes it's helpful to do that, but in this instance, I don't believe that's going to do you any good because 1.2 is not, I mean, what you might want to do is convert 1.2 into a mixed number, an improper fraction, so that you can see if there happens to be powers of 2. So that would be 1 and 1/5, which is 6/5, right? You could think of it like that. You could say 6/5 and ask yourself, now, is there any way for me to simplify that more? And still the answer is no.
Yeah.
Like splitting it up into subtraction, right? Sometimes you could do something like that, but that wouldn't help in this instance. So this is probably sufficient for the answer. Do you have the answer key?
No, not I don't have it.
Okay, yeah, just maybe put a star by that and go back and check just to make sure which version they want for you to write. But I think that's probably, if this is a non-calculator portion, they probably just want you to leave it like that, simplify it if possible. So for number 5, they even give you a hint. They say think quadratic. So so the first thing I'm going to do is rewrite this right here to -5 times 5 to the x. That's a trick. Do you see why? Because 1 plus x, you could go backwards. You can write 5 times 5 to the x. Those are the same thing there.
Yeah.
Do you see?
Yeah.
And I'm going to rewrite this as 5 to the x squared. So do you see how I have a 5 to the x and a 5 to the x? It's kind of like, let's call u 5 to the x, just so you can see it better. It's kind of like saying u squared minus 5u plus 6 equals 0. In fact, it's exactly saying that. This is called u substitution. So now I can factor this equation. It's a quadratic, right? And that equation is going to be u minus 6 and u plus 1. Did you follow how I did that? Whoops, I did that wrong. That's not right. Sorry, it should be u minus 3 and u minus 2. You see how I did that?
Yeah.
And then now I can set each one of these equal to 0. So u equals 3 and u equals 2. And remember, u is just 5 to the x. So 5 to the x equals 3. Whoops. 5 to the x equals 3 and 5 to the x equals 2, which means x equals log base 5 of 3, or x equals log base 5 of 2. And those are your two answers. Because I just took the log of both sides. I took the log base 5 of both sides. Got it?
Yeah.
Makes sense how I did that? And I know this is a calculator free portion, but remember, just to show you a little trick, a good thing to do is to store that. Remember this trick? If I store log base 5 of 3 for x, I'm storing that for my x. So every time I type in x, it's going to punch that number in. And now I just type in 5 to the 2x minus 5 to the x minus, or x plus 1 to the x plus 1 plus 6. And what should my answer be when I hit enter?
0.
Boom. Okay, got it?
Yep.
I showed you that trick before, right?
Yeah.
Okay. And I know this is no calculator test, but still it's good to know that little trick in case you are on a calculator part. All right, so number 6, I'm going to do what first? Remember, I'm trying to solve for x, so what do I do first?
So you can divide both sides by 4.
Good. So 3 equals e to the x, and now what?
Log base e of 3 equals x.
Good.
Oh,
Take the
natural log.
No, that's right. That's what you said. Log base e, which is the natural log, right?
Yeah.
So x equals the natural log of 3, and there's your answer.
Yeah.
Good. All right, here's a word problem. A psychologist sometimes uses this function to measure the amount L learned at time t. And notice that is a exponential equation, right?
Yeah.
Of sorts. The number A represents the amount to be learned. Suppose a student has to learn 200 vocab words. If the student has learned 20 words after 5 minutes, How many words will he learn after 10 minutes? Okay, so they're telling you that amount L learned at time T. And they're saying if a student has learned 20 words after 5 minutes. So we're going to use so when T equals 5, L equals 20. Is that what they're saying?
Yes, that is.
Seems like they haven't given us enough information here because we don't know what K, they didn't give us K. Is there anything else in this problem, like above the problem, that we're missing?
No, there's nothing that I don't think there's anything that we're missing. I think that's just as it is.
We have too many variables in here.
Hmm.
The number A represents the amount to be learned. Okay, so I guess A is 200.
Yeah.
I guess. Okay, so maybe they have given us enough information. So let's plug this in. 20 equals 200 times 1 minus E, that's not a variable, that's a number, right? Minus K to the T, which is 5. So we can solve this for K and then rewrite that in our equation and then plug in the other variables or the other numbers of minutes. Does that make sense?
Yeah.
So divide both sides by 200, you get 1 over 10
Mm-hmm.
equals 1 minus E to the negative 5K.
Yeah.
So now I'm going to subtract 1 from both sides. So this is negative 9/10 equals negative E to the negative 5K. Now I'm going to multiply both sides by 1, negative 1. I'm going to take the natural log of both sides. Got it? So the natural log of 9/10 equals negative 5K. So what does K equal? Negative natural log of 9/10 over 5. See how I came up with that?
Yeah.
Okay. So that's my K. And I'm not even going to, I'm just going to leave it like that as that mess. So now my equation, go back up here to my equation. My equation is going to be L of T equals 200 times 1 minus E to the negative ln of 9/10 over 5 times T, because that was my K, right? So now I'm going to plug in, and this is where it's nice to have that calculator. This is, I'm sure, a calculator on your calculator test, right? You
Yeah.
can't, there's no possible way you can do this
Yeah.
without a calculator. You would need something. You would need either a table or a calculator, but they don't use tables anymore. So I'm going to write this over here. Negative ln of 0.9, we'll just call it 0.9 over 5 times T. So we're figuring out how many words he'll learn after 10 minutes. So we're going to plug in 10 for T, or we'll call it X. So this is where it's good to know this trick. And now I'm going to just type in this formula, 200 times 1 minus E, which is above the ln. Whoops. How did I not get the 1 there? 1 minus E raised to the negative ln of 0.9 divided by 5, but I need to multiply that by x. So I'm going to call it negative x. So let's go insert. Negative, insert, negative x. See what I did there?
Yeah.
I put the x in front of it so that it multiplies the ln, because that's really what I want to do. That's what that t is doing right there. Do you follow my syntax there? Okay, so when I hit enter, that's going to tell me the answer, the L of t, how many words that he will learn in 5 minutes. Remember, he's learning 20 words in 5 minutes. So how many words will he learn after 10 minutes? It should be probably over
Twice
40, right?
Yeah.
At least twice the amount.
Mm-hmm.
I have a negative number here. Something, what I do wrong? Something I must have plugged in wrong. Did I forget the negative? Oh, K was a negative number. Do you see that?
Yeah.
K was a negative number. So actually this formula is going to be a positive.
Yeah.
So let's try it. Let's hit second enter and then go back through and just delete that negative in front of there. So it's probably going to be just a positive. Oh, 38. Wow. How about that? So 38 words is how many? So he's learning less words as time goes on. Now I'm going to store 15 for X. And I'm going to hit second enter. And now that's going to plug 15 for me for T. 54.2. So this answer was 38 words. This answer was 54.2. So notice he must be losing energy. He's actually learning less words as he goes. So how long will it take for him to learn all 200 words? So what we're trying to do now for this one, now we're calling L 200, right? Does that make sense?
Yeah.
So we're plugging 2 here. Let me do this in red. We're calling L 200. So we're solving this equation now. 1 minus e to the ln of 0.9 over 5 times t. Got it? So we're going to divide both sides by 200. 1 equals 1 minus e to the ln of 0.9 over 5 times t.
Yeah.
So I subtract 1 from both sides, I get 0, equals negative e to the ln of 0.9 over 5t. So I'm basically plugging that. Let's see. So I can take the natural log of both sides to solve this equation. I'm going to take the natural log. I can't do that. The answer is he will never learn all 200 words.
That works.
Does that make sense?
Yeah, that works.
Oh, do you have the answer key for this one?
No, I don't.
Yeah, and the reason is, do you understand why?
Yeah.
Because 200 was what he has to learn. That's why I was a little bit confused with this equation here, but that's what they told us it was. That means, see how he's learning less words as he goes?
Yeah.
His rate of learning words is decreasing.
Yeah.
He learned 20 in the first 5 minutes, 18 in the next 5 minutes. What is that?
Yeah.
16 in the next 5 minutes. You see how it's decreasing?
Yeah.
So it's decreasing to the point there's an asymptote, and that asymptote is 200. 200 is going to be your asymptote. It'll never reach it, which is what I was anticipating was going to happen here. Kind of a little bit of a trick question, because if you look at this problem, at this equation, you can't you can't get 0 by raising a number to a power. There's no way to get 0. So the answer is never. Okay.
Yeah.
All right. Which ones do you want to do first for the sake of time? Do you want me just to run through all of them? Do you want to do them? Do you want me to help you do them? Do you want me
I
just
think
to truck
that
through them?
sorry, can I see what's on the next page of the
Sure.
Jamboard? No, I think I'll go back to I think I'll do what's on page 4, yeah.
Okay. Again, whatever you want. We got about 20 minutes, and I mean, I can run through these really super quick, or you can practice them whatever you want. But I don't know how many things you have got it. Is it just these 2 pages that you have on it? Oh, that's it?
Yeah.
Oh, okay. We can probably get through this. Let me just do all of them.
Oh yeah, sure.
Okay. What's the log base 2 of 32?
So base 2 of 32, 5.
Remember,
Oh no,
good,
not
very
yeah,
good. Yep,
5.
no, you're right. 5. What's the log base 5 of 5?
1,
Good. What's the log base 9 of 1?
0,
Good. And what's the log base 12 of 0?
no solution.
No solution. Does not exist. Very good. All right, this looks a lot like that other one that we had, right? Let's do
Yeah.
change of base. Log 5 over log 7. Log 7 over log 3. Those are going to cancel. Log 27 over log 2. Log 2 over log 5.
Yeah.
So what cancels? Log 7 will cancel. Log 2's will cancel. Logs 5 will cancel. So this equals log 27 over log 3. We can convert that back. That means log base 3 of 27, right? Which just equals 3. Good.
Yeah.
This problem, we can do that same thing. Let's see. This is the negative of log base 2, or log of 2 over log of 3. And then on the bottom, we have, oh, this is a trick. This is one of those trick questions. Can you take the log of a negative number?
No.
No, you can't. So you say does not exist. They're trying to trick you with that one. Yeah. I would check the answer key for that one. Talk to your teacher about that one, because I've seen that a couple times. I don't know if it was you that asked me this before, but that's concerning to me that they would put that on there, because it seems like it has a solution. But you look at it right away, you just say, well, you can't do that. You can't take the log of a negative number, right? Okay, back to number 4. We can combine these together. So that's log base 27 of, remember, you multiply them. So multiplying them would be 8 times the log base 2 of 9. So now we can convert these. Let's see if this will help us. Log base 8, I'm doing change of base, over log of 27 times log 9 over log 2. And now we can actually mix them up. We can change the places of them. You understand what I'm saying? Like, we can rewrite this as log of 8 over log of 2 times log of 9 over log of 27.
Yeah.
Got it? Which
Yeah.
equals log base 2 of 8 times 1 over, I'm even going to flip it, right? 1 over log base 9 of 27. Actually, I don't have to flip that. That's not any better. Let's just keep it how it was. Log base 27 of 9. Well, this just equals 3. right?
Yeah.
You know that, right? And log base 27 of 9. So 27 to what power equals 9? So this is 3 cubed. So 3 cubed times what equals 3 squared? So that means 3x equals 2. That means x equals 2/3. So 2/3 is your answer here. And when I multiply those together, I just get 2. So 2 is your answer. Got it?
Yeah.
This problem right here, we start on the inside, the 7 log base 7, that just cancels and you just get 343. And 343, I'm pretty sure is just 7 cubed, isn't it? Isn't 7 times 3, 343? Or 7, or no? No, maybe to the 4th? What's 343 is a power of something. What is it a power of?
The power of 17.
Oh, no, it is a power of 7. Yeah. Because 7 times 50 would be 350. But we're just doing 7 times 49, so you have to subtract 7 from it, and that's 343. Do you follow that logic?
Yeah.
So this is 343. So this is just 3. Okay. What's the log base 4 of 64? I believe that's just 3. What's the log base 3 of 3? That's just 1. What's the log base 2 of 1? That's just 0. Good?
Yeah.
So this is log base 7 of 8 divided by log base 7 of 1/8, or 8 to the negative 1. And what can you do with this one right here? Do you see what you can do?
Yeah.
You can do your old change of base the opposite direction, right? Tell me what you're right.
You can just.
Remember how I did over here? What did I do when I had the log of something over something else?
Oh,
I
you
could
just change it to like 1 log.
correct. That's the change of base going in the opposite direction. So what would that 1 log be? Log
Log base 8 to the power of -1 of 8.
good, which just means 8 to the negative 1 to what power equals 8? So
It would
that
just be,
power is
answer would
what?
just be -8, -1. I'm sorry.
That's right, -1. Good. So for this one, let's see. I'm noticing this is a power of 2. So I could write this as, let's convert this base 2. So log base 2 of 49 over log base 2 of 4. And the log base 2 of 4 is just 2, right? You follow?
Yeah.
This just equals 2. So this whole thing is just equals 1/2 log base 2 of 49. And 49 is 7 squared. You see how I'm kind of just following? I'm following the carrot, basically. It's just leading me along. I'm like, oh, wait a minute. Now I can take that 2 down front. So that's just equal to log base 2 of 7. Got it? So this whole thing is just log base 2
Yeah.
of 7. So this is log base 2 of 8 times 7 minus log base 2 of 7. And how could I expand this out? Log base 2 of 8 plus, right?
Log base 2 of 7.
Log base 2 of 7 minus log base 2 of 7.
The answer is
So
just
what,
log base 2 of 8.
which is,
Log base 2 of 8.
which is?
3.
Perfect. Good job. All right. Warm up. If you can do this, triangle squared minus triangle minus 72. Okay, so that's just triangle is just x, right? So we're gonna factor this. 72 is 8 times 9, so it's a negative 9 and a positive 8. Just factoring. Got it?
Yeah.
So triangle equals 9 or triangle equals negative 8. It's basically just the same thing as x. They just want you to see that. And so now they're saying, oh, the triangle, oh, see, they're using substitution. So what was the triangle? The triangle is 3 to the x.
Yeah.
You get that? So 3 to the x equals 9, and 3 to the x equals negative 8, which means, what's x equal?
Equals.
X equals 2.
Yeah.
And this one doesn't have a solution.
Hmm.
Got it?
Yeah.
So they're talking about they're using what's called substitution. You remember I used the letter U. They're showing you that you can use triangle or square. You're basically just doing substitution. So this is just like factoring, right? It's negative 3 and positive 1, right?
Yeah.
So square equals 3 and square equals negative 1. Do you understand what I'm saying?
Yeah.
Do you get that? So they're saying if you can do this, then you can do this. And they're basically saying, oh, look, the square was just log base 2 of x. So log base 2, so the square equals log base 2 of x from that problem. It's the same problem. So log base 2
Yeah.
of x equals 3, or log base 2 of x equals negative 1, which means 2 to the third equals x, or 2 to the negative 1 equals x. So x equals 8, or x equals 1/2. There are your two answers.
Yeah.
Okay?
Mm-hmm.
Did I do that too fast, or you follow? You follow that okay, Mayor?
Yeah.
Yeah?
Yeah.
You'd tell me if you were confused, right?
No, I'm fine.
Okay. So remember what I normally do when I see those problems? I think I did it today, didn't I? I call it U. I write right here. I said let U equal at 5 to the x. Got it?
Yep.
All right.
Yeah.
You have some more problems? We flew through those pretty quick.
I want to kind of just review properties of logs and kind of just try with other problems similar to these.
Sure. Sounds good. So do you have some that you can write down and I can watch
Yeah,
you
I
try?
think I do.
Awesome. I'm going to go ahead and stop the